Okay, so here we have a linearized exponential model. Part A just says write down the equation, so that sort of implies there should barely be any calculating to do. We can just write it straight down. So clearly this is a straight line graph, except it's not y, it's log to the base 4 of p, and it's not x, it's t. Okay, so they're the two variables we're using. And then I need to find or state the y-intercept because that is already there for me. So really, the only thing I need to calculate is the gradient. So the gradient of that line, well, they've only given me 2 coordinates. I mean, I can see it's a negative gradient. So change in y is going to be 3.7 take away 5.2, and change in x 20 take away 0. I could of course have done 5.2 take away 3.7 over 0 take away 20, would have given me exactly the same answer. So let's get that. So 3.7 minus 5.2 all over 20. So that has a gradient of minus 3 over 40 or minus 0.075. It doesn't mention sort of rounding or how to give your answer, so either of those is fine. I'll go for decimals because later on we start rounding to 3 significant figures anyway. Okay, so the equation of this line, let's get rid of some of this. Okay, so again, we're just following the y equals mx plus c, but it's not y, it's log to the base 4 of p. And that is really important. When this has come up in an exam before, if you put y, you didn't get any marks at all, regardless of what else you did, whether you found the gradient. If you put y instead of log to the base 4 of p, it was 0. So so we've just worked out that the gradient is minus 0.75. It's not x, it's t, and then my y-intercept I can clearly see it's 5.2. Okay, so then part B asks me to write down the number of people in the venue when t is 0. So that was part A. So if I've now got this equation, I could write it back in its exponential form at this point, but to be honest, that's what part C is asking me to do. So the easiest way is just to take this equation of a straight line and sub in t is 0. So if t is 0, that just becomes log to the base 4 of p is 5.2. So p is 4 to the power of 5.2. Okay, so 1, 3, 5, 1, and then what does it ask me to round to? Correct, to 3 significant figures, so 1, 3, 5, 0. Okay, so part C. So I've got this linearized version of the equation. They told me that the original model could be modeled by that exponential equation. So if I linearize this, so I'll just try and fill that in over here. Okay, if you already know what this result is, then that is fine. So they are taking log to the base 4. So if you can see what's going to happen here without having to write this working out, that is perfectly acceptable because they haven't actually asked me to show how you get from this to linearized form, but you need to know these steps anyway, and if you're not totally confident, it's good to just double check it. So I'm taking log to the base 4 because obviously I can see that's what they've done. So then on the, sorry, I've actually skipped a stage of working out, haven't I? So I've skipped out, actually, yeah, sorry, let's do it step by step. So sorry, so my first stage would have been log to the base 4 of a, b to the t, and then they can be separated out, and then t, that t in the final term can come down as a coefficient. Okay, just check I've written everything out okay. Yep, I think I'm okay. So now, so again, if I compare what I've got here in terms of A and B to what I've got here, well, that's the key thing to have a look at. Where is the t? Well, that's my x variable. So here, t has a coefficient of minus 0.075, and here t has a coefficient of log to the base 4 of b, so they must equal the same thing. Okay, and same here, the constant is 5.2, and here the constant on its own is log to the base 4 of 8. Okay, that's a really common thing to do in a linearizing question. Okay, so it's really important that you can see what's going on there, that we've got the equation of a straight line from the graph, we've got the equation of a straight line from linearizing the exponential, and then we're just looking for the gradient and the intercept. Okay, so then I just need to take both of those out. So 4 to the power of minus 0.075 is b. Okay, so let's, it says 3 significant figures, so I'm going to put that b is 0.901, and then so a is going to be 4 to the power of 5.2, so a is 1350. And actually, yeah, so that's not a coincidence that that's the same as your answer to part, I think it was part B of this question, because if you look back to the exponential, a is going to be what you get when t is 0. Yeah, if you think about that, if you sub 0 in for t, b to the power of 0 is going to be 1, so a will be the initial population. So actually we did a bit of extra work there because we did already know what a was. Okay, for part D, we're asked to then find a value of p when we're giving a value of t. So you can use your linearized model, but for these final bits of the question, it's usually much easier to use the exponential model. So p is ab to the t, so a is 1350, and it told us to round to three significant figures, so I'm happy to use that value in my working. And then t, so just be careful, so see what t is measured in. Obviously, if it was measured in hours, we'd be putting in 0.5. It's not, it's measured in minutes, so that's going to be when t is 30. And it doesn't actually tell us what to round this to, so let's see what it is. So 1350 times 0.91 to the power of 30. Okay, so it doesn't specifically say what to round to, but it doesn't make sense to go to more than 3 significant figures when I've been using these values for 3 significant figures. And then we're talking about the number of people, so you can also then just say, well, that's really going to be 59 to the nearest person.